This is General Chemistry, cover the topic of gas, part 6. Previously, we talked about ideal gas law and its applications. We can use ideal gas law to compare gases in different situations. In order to do that, we first convert PV equal to nRT to the formula P1V1 over N1T1 equal to P2V2 over N2T2. In this formula, we can see physical properties of gas P, V, and T. Usually, when we compare two different situations of gas, the pressure P and the volume V can be in any units, as long as they are consistent on both sides. However, for the temperature T, that need to be in Kelvin. If they give us temperature in Celsius or Fahrenheit, that need to be converted to Kelvin first before we can plug into the formula. This formula can also be branched out into many other formulas. We already covered these formulas in the last video. But we don't need to memorize all of these formulas though. The only formula from ideal gas that we should try to remember is PV equal to nRT. You can derive other formulas pretty quickly as long as we understand the concept. So let's try taking a look at some practice questions here. For this one, an ideal gas sample initially at 7 atm, 2 ml, 8 Celsius undergoes a change that brings its pressure to 1 atm and temperature to 25 degrees Celsius. What is its final volume? It looks like we are comparing two different situations of gas here. Let's see what they give us here. 7 atm, that should be P1. 2 ml, that should be V1. 8 Celsius, that should be T1. And then 1 atm, that should be P2. 25 Celsius, that should be T2. And the final volume, that should be V2, and that's what they're looking for. To compare gas, we can convert PV equal to nRT to the formula P1V1 over N1T1 equal to P2V2 over N2T2. And we know that is one ideal gas sample, which means we can cross the N out. The amount's gonna be the same. So we are left with P1V1 over T1 equal to P2V2 over T2. So let's try. P1 gonna be 7 atm. V1 gonna be 2 ml. T1 gonna be 8 plus 273. That's gonna be 281 Kelvin. And gonna be equal to P2 is 1 atm. V2 is what they're looking for. And T2 is 25 plus 273, gonna be 298 Kelvin. Alright, so we're gonna get V2 equal to 7 times 2 over 281 times 298 over 1. If we estimate 281 to 280, we can cross this, and this is gonna give us 40, and then this is gonna give us 20. And we should get about 14.9 milliliter here. And that is the answer. And if you plug it into a calculator, that should give something about 14.8 milliliter. Alright, let's try the next question then. For this one, a sample of gas normally kept at 35 Celsius occupies a volume of 670 milliliter and exerts a pressure of 1 atm. But when this gas is moved to a new room, it occupies 555 milliliter at 1 atm. What is the temperature in Celsius of the new room? Again, we are comparing two situations of gas here. And what they give us is T1 over here, 35 degree. 617, that's gonna be V1. 1 atm gonna be P1. And then 555, that's gonna be V2. 1 atm here gonna be P2. And the temperature in the new room, that's gonna be T2. And that is what they're looking for. To compare the gas, we're gonna convert PV equal to nRT to the formula P1 V1 over N1 T1 equal to P2 V2 over N2 T2. And since it's one sample of gas, N can be crossed out, and the pressure is always 1 atm, P can be crossed out too. So we are left with V over T. As a reminder, T temperature need to be in Kelvin. They give us the temperature in Celsius here, and they ask for another temperature in Celsius. But we cannot plug that number in directly. We have to convert that to Kelvin. Let's try. V1 is 617 milliliter, and that's over T1, which is 35 Celsius plus 273, gonna be 308 Kelvin. And that's gonna be equal to V2, which is 555 milliliter. And T2 is what they are looking for. So T2 gonna be equal to 555 times 308 over 617. Let's see what we can do here. If we estimate this to be 616, then we can cross this 1 and 2, and we should get 555 divided by 2, so it's going to be about 277.5 Kelvin. Yes. And they asked about temperature in Celsius though. So we know that Celsius gonna be equal to Kelvin minus 273. So we can plug in 277.5 minus 273, and we're gonna get 4.5 Celsius, and that is the answer. And if you actually use calculator, you probably get something about 4.05 degrees Celsius. Alright, let's take a look at another example then. For this one, an empty balloon expands to 1.5 liter after it is filled with 0.5 gram of helium gas at 35 Celsius and pressure of 1.2 atm. An extra amount of helium gas is then added to further expand the balloon to the final size of 12 liter. Pressure and temperature remain unchanged. So, how many grams of the extra amount of helium were added to the balloon? Let's try to clarify what they are asking here. So basically, they pump the helium gas in to make a smaller balloon, and then they continue pumping the gas in more to make a larger balloon. So we know that in smaller balloon, we have 0.5 gram of helium, and that is 1.5 liter, and the temperature is 35 Celsius with pressure equal to 1.2 atm. And then they keep pumping helium in a little more. So inside here gonna be 0.5 gram of helium previously there, plus an extra amount of helium that pumped in a little bit later. So to make it a little bit easier, we can call this total. Alright, and we have the volumes. The final volume is 12 liter, and temperature also at 35 Celsius, and pressure also at 1.2 atm. Since we are comparing gas here, we're gonna be using P1 V1 over N1 T1 equal to P2 V2 over N2 T2. But we know that T is the same throughout and P is the same throughout, so we can cross P and cross T. So we are left with V over N. They give us V 1.5 liter and 12 liter here, but they didn't give us N. Instead, they give us mass of helium 0.5 gram and 0.5 with some extra amount of helium. But we know that N, which is mole, equal to mass in gram over molecular weight in gram per mole. That means we can plug M over M here into the formula on the left. So we're gonna get V1 over M1 over M1 gonna be equal to V2 over mass over molecular weight. But there is only helium gas in the balloon here, which means molecular weight will stay the same throughout, so we can cross the big M out, and we should be left with V1 over mass 1 gonna be equal to V2 over mass 2. I'm gonna move our new formula up a little bit. V1 is 1.5 liter and M1 is 0.5 gram. V2 is 12 liter and M2 is the total mass, so let's say M total from here. So we can get M total to be equal to 12 times 0.5 over 1.5. That can cross out to be 3. So we're gonna get M total to be 4 gram here. But they ask about M extra here, the extra amount. So let's put it here. So M extra gonna be equal to the 4 grams minus 0.5 gram that we have earlier, and it's gonna be 3.5 grams, and that is the answer. So if you practice a little bit more, you should be more comfortable with ideal gas law and its applications.